This video goes through calculating the area of non-right angled triangles. Okay, so you remember that when you have a right angled triangle, the area is equal to a half times the base times the height. So right angled triangle, height and base. So we've got a half times base times height, or if we didn't have a non-right angled triangle, we could use the same formula as long as we had that perpendicular height. Okay, but what if we don't have a right angle triangle, and what if we don't have that perpendicular height? Again, our triangle is labelled exactly the same way as for our sine rule and our cosine rule, and our formula is area is a half AB sine C. Now the formula on your formula sheet is in the form of the last one here. Area is a half BC sine A. Which formula you use, which combination you use, it really depends on what information you're given in the question. So as you can see off to the side here, I say if we have two sides and the included angle, now remember that's included means the angle in between. So if I had side C and side A, I would need angle B to be able to do the area of a triangle. Now, if I did have that, I would therefore use this form of the formula because I have my length A, I have my length C, and I have my angle B. So it depends on the information you're given. Use the formula on your formula sheet and just rearrange the information. The more you use the formula, the easier it will become in terms of what it is, because you'll notice that your angle and these letters here don't match. Okay, so if you've got sine B, then you're multiplying your sides A and C. If you've got sine C, you're multiplying your sides A and B. So think about what you're doing more so than trying to memorize formulas. So let's look at some examples. Calculate the area of the following triangles. Now in the first one, you can see that I have the two sides and I have that included angle there. So let's label my sides. It's little a, little c, and I have angle B. So my area formula is going to be a half AC sine of B. So remember, it's always the two sides and that included angle, because sometimes you might not just have that information. So you need to make sure you're labeling correctly and putting the right information into the formula. So let's substitute what we have. Half times 6 times 7 times sine of 30, and you can then go to your calculator and work that out. And you should get 10.5. It is area, so it's centimeters squared. So I want you to pause the video and have a go at the next one on your own. Okay, so as you can see, if I label my sides, little a, little b, and I have my angle C. So when I write my formula, area is a half times AB this time, times sine of C. Again, two sides and that included angle, that angle in between. So I've got a half times 77 times 82 times sine of 34 degrees and 22 minutes. Go to my calculator and plug in what we have, and you should get approximately 1,782.09 centimeters squared. Now note there could be variations of these questions. How could I make it more complex? Well, maybe you don't have that included angle and you might need to use your sine rule or your cosine rule to find unknowns to then be able to find area. So we could use combinations of our different rules and then come up with area. So just remember that. So key point, two sides and the included angle, the angle in between. If you don't have that, you might need to use your sine rule or cosine rule to find out the information that you need in order to do area. Now our next example, we're going to calculate the size of the angle given the area. Okay, so we're going to work backwards here. We're going to need a triangle. Again, draw any triangle you want, label it however you want. So AB is 7 centimeters, AC is 15 centimeters, and we have that an area is 39 centimeters squared, and it wants us to calculate the angle of angle BAC. Now remember that middle letter is our angle, so in this case it's angle A. So when I write my formula, I'm going to label my sides. I want that sine of A, so its area is a half BC sine of A. Again, remembering we have the two sides and that included angle. Substitute the information, 39 equals a half times 7 times 15 times sine of A. So work out what you have on the right-hand side. We have 39 equals 52.5 sine of A. We want to get that sine A on its own, so we're going to divide both sides by 52.5. It's being multiplied, so we do the opposite and divide. So now we're left with sine of A equals 39 divided by 52.5. Which is approximately 0.74. So our our A is going to be approximately inverse sine of 0.74. And we get approximately 47.98 degrees. So therefore, angle BAC is approximately 47.98 degrees. Now pause the video and have a go at the next one yourself. It's very similar, so think about that process and go through it. So let's start by drawing a triangle ABC. AB is 11.2 millimeters, AC is 12.8 millimeters, and my area is 56.48 millimeters squared. I want angle BAC, so that middle letter is the angle I want, so it's angle A, which is the included angle. So there's our two sides and our included angle. So the formula is going to be area equals a half, label our sides CB, so BC sine of A, substitute the information we've got, 56.48 equals a half multiplied by B, 12.8 multiplied by C is 11.2 sine of A. Multiply what we have on the left-hand side, 56.48 equals a half times 12.8 times 11.2 is 71.68 sine of A. Now I'm going to divide both sides by that 71.68. So they cancel. So now I have sine of A equals 56.48 divided by 71.68 is approximately 0.79. So our A is approximately inverse sine of that. And we get approximately 51.99 degrees. So therefore, angle BAC is approximately 51.99 degrees. Okay, so I suppose the biggest thing here is getting used to those formulas. Again, just think you've got two sides in the included angle. So whenever you write your formula, if you have AB, then the angle you'll have is sine C because it's the middle. If you have AC, then the angle you'd have would be B. If you have a half BC, then the angle you have is A. Just takes time to get used to it. Complete the exercise. So exercise 4I, question 2 and question 4 to 10.